Hi students, let us try to understand a spherical mirror from the NCERT books we are taking it. Student, see, the reflecting surface of a spherical mirror may be curved inward or outward. So see, reflecting surface here is the concave is there. So reflecting surface is what is this is inward, or that is reflecting surface is what is this is the outward. Okay, this is what the point meaning of this one. A spherical mirror whose reflecting surface is curved inward, that is faced towards the center of the sphere, is called the concave mirror. See, again you see the definition, student. You might get confused here. A spherical mirror whose reflecting surface is curved. So it is reflecting surface is curved inward, that is faced towards the center of spheres, that is what called concave mirror. Next one, a spherical mirror whose reflecting surface is curved outward is called convex mirror. So this is the what is convex mirror, this is the concave mirror. The systematic representation of these mirror is shown in figure 10.1. So it is 10.1. You may note that this diagram that the back of the mirror is shaded. Okay, so here you see back of this is the shaded, here is also shaded. So systematic representation of spherical mirror, the shaded side is not reflecting. Now you may now understand that the surface of the spoon curved inward can be approximated to the concave mirror, and that surface to the spoon bulged outward can be approximated as convex mirror. Before we move further on a spherical mirror, we need to recognize and understand the meaning of the few terms. These terms are commonly used in discussion about spherical mirror. The center of the reflecting surface of the spherical mirror is point called the rule, called the pole. See student, this point is very important. Pole is very important. They are saying the center of the reflecting surface of the spherical mirror is called the pole. It lies on the surface of the mirror. The pole is usually represented by the letter P. Okay. The reflecting surface of the spherical mirror forms a part of a sphere. This sphere have a center. This point is called the center of curvature of the spherical mirror. It is represented by the letter C. Please note that the center of curvature is not a part of mirror. It lies outside its reflecting surface. The center of curvature of the concave mirror lies in front of it. However, it lies behind the mirror in case of convex mirror. You may note that in figure 10.2a and b, the radius of the sphere of which the reflecting surface of a sphere, the spherical mirror forms a part, is called radius of curvature of the mirror. Radius of curvature of the mirror. So somewhere this point it will be the radius of curvature. Okay, and pole already I told you, the center of the reflecting surface of a spherical mirror. The center of reflecting surface of a spherical mirror point called is the pole. That is okay. It is represented by the letter R. You may note that the distance PC is equal to the radius of curvature. So you can go 10.2 student, 10.2. So PC you see, where is the P and C? This. So this is saying that this is the radius of curvature, student. Right. Now go for the next one. Imagine a straight line passing through the pole and the center of curvature of a spherical mirror. This line is called the principal axis. Remember that the principal axis is normal to the mirror at its pole. Let us understand the important terms related to mirror through an activity. Okay. So they are saying do not look at the sun directly or even into mirror reflecting sunlight. It may be damage your eyes. Hold a concave mirror in your hand and direct its reflecting surface towards the sun. Directed the light reflection by the mirror onto a sheet of paper held close to the mirror. Move the sheet of paper back and forth gradually until you find on the paper sheet bright sharp spot of the light. Hold the mirror and the paper in the same position a few minutes, what do you observe? The paper will start burning. The paper at the first began to burn, producing smoke. Eventually, it may even catch fire. Why does it burn? The light from the sun converged at a point as a sharp bright spot by the mirror. In fact, this spot of the light is image of the sun on the sheet of the paper. This point is the focus of the concave mirror. The heat produced due to the concentration of sunlight ignite the paper. The distance of this image from the position of the mirror gave the approximate value of the focal length of the mirror. Let us try to understand the observation with the help of a ray diagram. Okay, observe 10.28, this one closely. A number of rays parallel to the spherical uh, parallel to the principal axis are falling on a concave mirror. Observe the reflected rays. They are all meeting, interacting at the point on the principal axis of the mirror. Okay, so all reflecting back and principal axis of the mirror, they are reflecting back. The point is called the principal focus of the concave mirror. So this is called F is principal focus. Similarly, observe the figure 10.2b. How are the rays parallel to the principal axis reflected by the concave mirror? The reflecting rays appears to come from a point on the principal axis. This point is called the principal focus of the convex mirror. The principal focus of is represented by the letter F. The distance between the pole and the principal focus of the spherical mirror is called focal length. So this is the pole and this is the F, focal length. It is represented by letter J, letter F. The reflecting surface of the spherical mirror is by and large spherical. spherical. The surface then has a circular outline. The diameter of the reflecting surface of the spherical mirror is called the aperture. In a figure 10.2, the distance Mn represent the aperture. So Mn is what is? This is the M and this is N. This is going to be aperture. Okay. We shall consider our discussion only such a spherical mirror whose aperture is much smaller than the radius of curvature. You know, is there is a relationship between the radius and curvature or and focal length of the spherical mirror? For a spherical mirror of the small curvature or the radius of curvature is found to be equal to the twice of focal length. We put this as r is equal to 2f. This implies that principal focus of a spherical mirror lies midway between the pole and the center of the curvature. So this is all about what is student if you do concave or convex mirror or the spherical mirror. Thank you so much for watching, friends.